and thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBV Elektronik.
Welcome to the Passion for Technology podcast. We're all familiar with ultraviolet light, at least from the last time that we got sunburned. UV light has been and still is being used in many different ways within industry and agriculture. It replaced conventional mercury lamps in many applications. UV light provides greater robustness and more design freedom. Market analysts at Allied Market Research expect the global UV LED market to grow from $0.35 billion in 2019 to $1.71 billion by 2027. One of the key drivers is the increased use of UV LEDs for drying paint and curing adhesives. For these applications, special diodes are used which emit light in the UVA spectrum. In today's podcast episode, presented by leading European semiconductor distributor EBV Elektronik, we would like to talk about the possibilities offered by UVA LEDs and put the spotlight on their use in industrial applications. I'm happy to welcome Anton Sonneveld. Anton, you're joining us from Broadcom, a leading supplier of semiconductor and infrastructure software solutions, where you're a business development manager for LEDs and part of the European organization. From what I understand, you've held various positions in sales and marketing dedicated to LEDs over the past 13 years. Hi, Anton.
Yes, hello, Mustafa. Good afternoon.
And we're also joined by Dr. Dieter Groß from EBV. Dieter, you're a business development manager for IoT, home, and building at EBV Elektronik, and you've been with EBV Elektronik since 2017 and serve as business development manager for lighting. And you also have a PhD degree in optoelectronics and spectroscopy. Hi.
Hi, thanks for this introduction.
Anton, can I call you Tony?
Yes, please.
Tony, from what I understand, the sun is a big player in terms of UV lighting. But what is it actually? How would you describe UV light?
So UV light, which is in short ultraviolet, is defined as a form of radiation that is part of the electromagnetic or EM spectrum, which has a specific wavelength. So it starts at 100 nanometer, which is known for X-rays, and shorter wavelengths, which is 400 nanometer, which is the visible light. So that's something we see also with visible LEDs. So in general, we have different kind of UV light. So it's divided into UVA, UVB, and UVC. If we are talking about UVA and also UVA light from the sun, 95% reaches the Earth's surface. If you look at UVB, for instance, it's only 5% of the sunlight which contains UVB reaches the Earth's surface. And for UVC, usually UVC light does not reach Earth's surface at all. Also, as we know, UVC is having the lowest penetration depth, so it reaches the outermost layer of the skin. So it's very dangerous. While UVA, for instance, is usually the safest spectrum we have.
Dieter, where is UV light being used in industrial applications?
You already mentioned that it is used in curing. So curing means curing of lacquer in 3D printing, where you concentrate the light really to the point where you print. This is a benefit for the LEDs, for example. But you can also know curing when you go to the dentist, and the dentist works with UV. That's also from UV LEDs typically. Another thing is we mentioned that UV light is significant in the sun spectrum. In the ambient spectrum we have, it is important for plants and animals. In this way, you have animals, they see also UV light. So if you have, for example, chicken, and you light them up only with the visible light, which is visible for humans, they are missing one color. So this is irritating them. So if you see your neighbor in false color, so they will be stressed for the false color. And this would not be the right way to hatch animals. The other way, you know, also when you eat tomato in the winter times, then it will not have the smell of the summer, the taste of the summer. This is partially also something which is related to UV. UV really creates aromas and also other secondary ingredients, which is important for the flavor and also for other things in plants. So there are special applications in horticulture lighting where UV is essential. Also, for example, the bumblebees, they will not fly from flower to flower if there's not any UV light there. UV is also very known for us in the amusement when you go to the discotheque and you have the so-called black light. This is the effect of fluorescence which is used. You cannot only use it in amusement, but technically you use it for material verification. So you can use it for crack detection, for example, in medical analysis, you have fluorescence markers where you also need to shine on them with UV. And when you look to a banknote, you see the verification is typically using a UV lamp for this. Another application is phototherapy. So you can also treat diseases with UV, especially UVB is there, an application. And in these current days of the pandemics, it is also quite important to use UV for disinfection. So this is something which is a traditional usage of UV with the mercury tubes. And now we have huge demands to look on UV applications. What can we do in these days?
Disinfection in particular, how does that work?
So with disinfection, you have two different main routes typically. Traditional disinfection is UVC with mercury tubes, where you really attack the DNA of the microbes and the pathogens, and you alter basically their genome. The other way is oxidation, so maybe photocatalytic oxidation or really oxidation by natural light disinfection, blue light disinfection, where you induce radicals and this attack then these cells and reduce or oxidate everything down to water and carbon dioxide basically. What is also special when you go to these oxidation processes, you typically use UVA LEDs or near UV LEDs or only blue LEDs. And you can use this either with a photocatalyst. So this is a photocatalysis route called, where you work on a surface. Due to the catalyst, it is a quite effective way to do this. And you have additional benefits, especially for air purification, that you remove odors and you remove toxic gases, aerosols, and pollen will also be attacked in this way, which is really helpful if you suffer from allergies.
Dieter just mentioned the near UV range. I just want to highlight that Broadcom qualifies near UV range at 400 nanometers up to 425 nanometers. And we are offering 3 different parts in that range, which are suitable. So 405 nanometers, 415 and 425 nanometers. So I think that's interesting to have those parts also in our portfolio, as it has lower safety requirements.
Tony, now that we've heard about UVA, UVB, and UVC, are they all being used to the same extent? Would you consider a particular one to be the most relevant right now?
Currently, it's that the most interesting market and the market where we have most of the requirements and questions is the curing market. We are talking here mainly about inks and printing and coatings, but also dentistry, which was highlighted by Dieter. And these are typical the ranges for UVA LEDs and near UV LEDs.
What benefits do UVA LEDs offer, Dieter? They're popular in curing and drying processes, as we heard. Why are these areas witnessing a boom?
The LEDs, they offer really a much higher power density. If you compare it to the traditionally used mercury lamps, so you have a generation of photons which is 10,000 times higher than a mercury tube. When you compare it on a chip level, if you compare it on a package level, you end up still with a 100 times higher intensity, which is coming out from this package. Another thing is the wall plug efficiency of an LED in the UVA range is around 50%, roughly. That's similar to what we have also with blue LEDs, because they are based on this technology, actually. So when you compare, a mercury tube has an efficiency of 30%, for example. UVC LEDs, they are still emerging for the moment on the market. So there we have efficiencies in the range of 2%. Another thing why they're popular in curing is that the UVA photons, they have a deep penetration compared to the UVC, which is just on the surface. So if you want to try something deeper, then UVA has special benefits in this way. Another thing is UVA LEDs are just simpler to use because it's just an LED where you have a voltage in this range of a little bit less than 4 volts. And you can use the same drivers and same techniques as you use it with LEDs. You can use PWM dimming and everything else.
Tony, what's special about UV LEDs compared to standard visible light LEDs? I mean, you're a semiconductor manufacturer. Could you explain a little bit about recent advances made in terms of material and production technologies?
Yeah, that's a good point. Thank you, Mustafa. So as we know, LED technology is in general revolutionizing the lighting industry since many, many years. And of course, this is due to some factors. So the known ones is offering, of course, energy savings. There are toxic-free materials. It has a very long lifetime, very small, tiny footprints. And we have, of course, also a low heat generation. Let's have a look at the materials, for instance. So the optics materials. Usually not all of those are transparent to UV radiation. So we have lime glass, for instance, which is not transparent. We are mainly using silicon and quartz, which is highly transparent to UV. And it's also known for their high light transmission efficiency and also the ability to withstand UV exposure with minimal material degradation. Another point is the light coverage. Here we are talking about the beam angle. So the beam angle usually determines the width of amount of light being distributed on the target area. We are offering different viewing angles here, so 130 and 60 degrees, for example. They are having a wider spread, which is suitable for workspaces and surfaces. But there is also a smaller viewing angle available of 35 degrees, which is more suitable than for applications where you need a spotlight. Additional, it's having a more concentrated beam, which also leads to a higher intensity. I already mentioned the lenses before, but this leads also to a better package robustness. So we are also using quartz lenses. Quartz lenses are having a greater resistance to harsh chemicals, also better robustness against deformation and contaminants. And then, of course, the heat management. As we know, poor thermal management results in degradation of performance and also the reliability of an LED. So a very low thermal resistance makes it easier to dissipate the heat from the device and also ensures that the junction temperature is at appropriate operating level.
UV light is not completely harmless to the skin and eyes, Dieter. What type of safety precautions can and should be taken?
Thank you. That's a good question. So the light becomes more and more dangerous the shorter the wavelengths. So we have a deep penetration of the UVA light, but anyway, it is not so harmful for the skin than UVC light. Another thing is UV LEDs. They are normally only emitting just narrow spectrum compared to the mercury tubes, which emit from below 200 nanometers in the UV to the near infrared range. So a whole range. In this respect, the UVA LEDs are safer than a conventional mercury tube. The UVA LEDs will never emit any wavelengths which can create any ozone. You don't have any problems about glass breakage and these safety issues. Nevertheless, the UV light undergoes some regulations, and this way you need also to do typically safety requirements. Never look into an LED. It is too bright light source. If it's a UV LED, UVA or UVC, you need to wear appropriate safety. For the skin protection, you should cover your skin, and it is also important to have the appropriate warning labels on your devices. When we compare UVC radiation to UVA radiation, you can look to the norms and you see that typically UVC light is classified 1,000 to 100,000 times more dangerous than UVA light. So for this, it is also important to pay attention what radiation you have.
LEDs don't just use less energy, they also emit much less heat than conventional mercury lamps. Tony, what does this mean for the entire system? What benefits does this provide for system setup and operation?
Conventional lamps emit extensive heat together with the light to the ambient environment. And of course, they also heat up the area being shined. So if you look at UV LEDs, just like other LEDs, the UV light emits at the front side, while the heat is generated at the back side, so at the junction of the LED dies. So the heat can be channeled out through a package lead at the back. So the area where the LED light is shined on with UV light will not be heated up. Our Broadcom LEDs, for instance, are having a very low thermal resistance of 6 degrees per watts. And this also helps to channel out the heat easier from the package. An additional effect is that a smaller or less costly heatsink is needed which also translate, of course, into a better design flexibility. So if you look at the data sheet, you will find also some extra information and easy steps how to do the LED thermal management.
Dieter, when you replace mercury tubes by UVA LEDs, are there any special aspects to consider? Anything related to filter or reflector systems or environmental conditions?
Thank you for this question. So when you design with UVA LEDs, basically most of the things becomes much more easy. If you start with the voltage, an LED is driven on a chip level with 4 volts. So you don't need any high voltage, what you would use for a mercury tube. The package is obviously much more robust with an LED compared to these large quartz tubes used for mercury tubes. So they are really robust against vibration and breakage. If you look to the lifetime, an LED has a lifetime typically of several 10,000 hours, where a mercury tube is replaced after 5 to 10,000 hours already. When you look to the temperature range of operation, a mercury tube has typically a quite narrow range of efficient operation, while an LED can be used even in a fridge or in a freezer and also at quite warm condition unless you remain below the chip junction temperature of 90 degrees. An UVA LED can never produce any ozone, which is typically a problem in the first hours of the mercury tubes when you do the burn-in. So you can really have some creation of ozone because there are some peaks in the mercury. If you don't use the right material, then you will get the wrong peaks and you get ozone creation. This is which you may refer in your question about the filter. If you look to the total cost of ownership of an LED system, then it is typically much better than with a mercury tube, but you have slightly higher initial invest costs. The thermal management Tony mentioned already, it's much better defined. So you have the heat pumped out at the back, no heat radiation on the front. You have just the UV light you need. And what is also important that the LEDs, they have really high design freedom. So you can use advanced optics, especially you can also use die-cast silicon optics. And if you're working in a little bit more harsh environment with many organic vapors, like in rapid curing, then you may use quartz lenses this way. What I did not mention is the efficiency of the UV LEDs is also higher. So this is also a benefit for you, which you can use, and you don't need too much energy in this way.
Will we see any conventional mercury lamps in use in the future at all? What do you think, Tony?
So the conventional mercury lamp technology is also improving over the time. So the UV lamps will not completely disappear from the market. However, mercury will be possibly banned in the next 5 to 10 years. So this will, of course, also help to move the technology to UV LEDs, which includes also UVC. So we believe the UVC segment is one of the most interesting and growing areas. This is including markets like healthcare and the medical sector. Dieter already described some of the applications before, but very important is, of course, disinfection of surfaces, water and air purification. We also have to see that UVC LEDs will further improve in terms of efficiency, but also price-wise. So it can also take over the leadership in these segments. Broadcom will also release UVC LEDs mainly end of Q1 2022.
Our podcast is named Passion for Technology, and we're also interested in the origin stories of each and every one of our guests. So I'd love to know when and how you developed your individual passion for technology. Tony, when did you develop and how did you develop your passion for technology?
Yeah, well, I was always fascinated by light and light appearance. So from my side, it was more a combination of passion for light and electronics. I even worked for a period in a candle factory. After that, I moved into the electronic industry to a PCB manufacturer and learned how complex, small, and innovating technology can be. Finally, then I got the opportunity to combine both interests in light and electronics mid of the 90s by joining an LED manufacturer, where I really saw great new developments in the LED market during the years, from the first blue LED to the market release of the white LED, which to the breakthrough in the lighting industry. And right now, of course, UV LED light is a new exciting and booming area.
Dieter, what about you? Where does your passion for technology come from?
When I look back, I would say it comes a little bit from the way that I was watching Star Trek in my childhood, playing with some of the special toys which involve more technique. So at my time, it was more clean. I was soldering also some electronics, PCBs for children, kids. Then later, after school, I did a volunteer year for solar energy in a developing world country. And we were promoting solar lighting. With this, I came back from this country studying physics, and I found out that LEDs became the efficiency leader in lighting. So this was what made me passionate about LEDs. Now that I had also the background from developing countries where disinfection is a major issue, so everything comes now together with UV LEDs and disinfection. So that's really a point where I really love to work, and which is really in my passion for my everyday work and helping a lot for this market.
It's so interesting to hear and listen to you and hear where and how passion for technology forms and where it leads us. Dear listeners, please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Tony, Dieter, thank you very much for joining us for this episode.
Thank you very much, Mustafa.
Thank you.